Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Cyclohexane is a saturated cyclic hydrocarbon, while cyclohexene is an unsaturated cyclic hydrocarbon containing AC is equal to C double bond. Simple chemical tests that detect unsaturation, the C is equal to C double bond, can be used to differentiate them. Moving on to the next step. Cyclohexene undergoes electrophilic addition with bromine water, decolorizing the orange-brown Br2 solution to give a colorless product, trans 1,2-dibromocyclohexane. Cyclohexane does not react with bromine water under normal conditions, no UV light, so it does not decolorize Br2H2O. This test successfully differentiates the two. Moving on to the next step. Cyclohexene reacts with cold dilute KMnO4, Bayer's reagent, via S-wind hydroxylthione, causing the purple-violet color of KMnO4 to decolorize, forming a colorless diol and brown main O2 precipitate. Cyclohexane does not react under these mild conditions, so the purple color is retained. This test also successfully differentiates the two. And for the final step, Tollens reagent is used to detect aldehydes, oxidizable carbonyl groups, not C is equal to C double bonds. Neither cyclohexane nor cyclohexene is an aldehyde, so neither would give a silver mirror reaction. Tollens reagent cannot differentiate them, eliminating option C. Since both Br2H2O and Bayer's reagent independently and reliably differentiate cyclohexane from cyclohexene by detecting the double bond, option D, both A and B, is the most complete and correct answer. Why other options fail? Option C. Tollens reagent fails because it tests for aldehydes, not alkene unsaturation. Options A and B alone are each correct but individually incomplete compared to option D. Therefore, the correct answer is D. Therefore, the correct answer is option D.